today's tutorial we shall go over laws of indices. But before then, what is index notation? Index notation is a method of shortening the product of numbers of equal factors or numbers that are the same. For example, if you have 2 times 2 times 2, you say this is equal to 2 raised to power 3. You have 3 times 3, this is equal to 3 raised to power 2. You have 4 times 4 times 4, this is equal to 4 raised to power 3. Just a method of shortening the product of numbers of equal factors or numbers of this that are the same. So let's go into laws of indices. The first law we are going to pick here is multiplication law. Multiplication law states when numbers with equal bases are being multiplied, their powers are added. So if you have 2 raised to power 5 times 2 raised to power 3, this is equal to 2 raised to power 5 plus 3, which is equal to 2 raised to power 8. So when the bases are of the same value and it has to do with multiplication, what you do is you add the powers of the value together. So if you have again 3 to the power of 4 times 3 to the power of 5, this is equal to 3 to the power of 4 plus 5, which is equal to 3 to the power of 9. Does that make sense to you? Hence, we can say when we have a to the power of x times a to the power of y, this is equal to a to the power of x plus y. Now let's go over to the next law, which is division law. Division law states when dividing numbers with equal bases, the power of the divisor is subtracted from that of the dividend. We have 3 raised to power 6 divided by 3 raised to power 5. This is equal to 3 raised to power 6 minus 5. This is the divisor and this is the dividend. So it is being subtracted from that of the dividend, which will give us 3 raised to power 1. Say if you have again 5 to the power of 8 divided by 5 to the power of 5, this is equal to 5 to the power of 8 minus 5, which is equal to 5 to the power of 3. Hence we can say if we have a to the power of x divided by a to the power of y, this is equal to a to the power of x minus y. Now let's go over to the next power, which is the power law. The power law states if a number which is raised to a certain power is again raised to another power, it is said to be in powers. This includes even you have question like 2 raised to power 3 all to the power of 2. This is equal to 2 raised to power 3 times 2 times 2, which is equal to 2 raised to power 6 equals to 2 raised to power 6. Or we can easily say if we have a function like a to the power of x all to the power of y. This is equal to a to the power of x y. One more other example. We have a function like 5 to the power of 2 all to the power of 3 is equal to 5 to the power of 2 times 3, which is equal to 5 to the power of 6. So we go over to the next law, which is the product power law. When the product of different factors are raised to a certain power, perhaps in a bracket, the power is distributed over each factor in the bracket. Say we have 3p q all to the power of 2. This is equal to 3 raised to the power 2 times p raised to the power 2 times q raised to the power 2, which is equal to 9p square q square. So that's just it. The power is distributed to all those factors in the bracket. Say if you have again 5 xy raised to the power 3, this is equal to 5 to the power of 3 dot x to the power of 3 dot y to the power of 3. So if you simplify, you get your answer. Now let's go over to the next law, which is the zero index law. The zero index law states when any number or quantity is raised to the power of 0, the result is 1. Now if you have a question like 2 raised to the power 3 divided by 2 raised to the power 3, you know this is equal to 2 raised to the power of 3 minus 3, which is equal to 2 raised to the power of 0. The zero index law says that this is equal to 1. Meanwhile, any number raised to the power of 0 is equal to 1. If you say 5 to the power of 5 divided by 5 to the power of 5, this is equal to 5 to the power of 5 minus 5. 5 minus 5, which is equal to 5 to the power of 0. This is automatically equal to 1. That is zero index law. And with this, we can be able to say that a to the power of 0 is equal to 1, 5 to the power of 0 is equal to 1, 6 to the power of 0 is equal to 1, 100 to the power of 0 is equal to 1. Any number raised to the power of 0 is equal to 1. So let's go over to the next law, which is the negative index. A number is raised to a negative index equals the reciprocal raised to the same positive index. I mean, when a number is raised to a negative index, it equals the inverse raised to the same positive index. Inverse. Say if we have function like 3, we have 3 raised to the power of 6 divided by 3 raised to the power 9. Say this is equal to 3 raised to the power 6 minus 9, which is equal to 3 raised to the power minus 3. This is a negative index number. Now, the law says that this equals that 3 raised to the power minus 3 equals 1 over 3 raised to the power 3. That's the inverse of each positive. Inverse of each positive. So we have other functions again like 9 to the power of negative 2 is equal to 1 over 9 to the power of 2. We have other ones again like 3 to the power of negative 2 is equal to 1 over 3 to the power of 2. That's just it. So the inverse positive equals that of each negative index. Does that make sense to you? So say if we have a function like 5 raised to the power minus 4, this is equal to 1 over 5 raised to the power 4, which is equal to 1 over 5 raised to the power 4 is 625. So this is equal to 1 over 625. So let's go over to the next power, which is the roots power. The roots power states that this power involves the method of showing the indices of different roots. You can say square root or cube root or fourth root. Say if we consider a number like 2 raised to the power 1 over 2, this is equal to the square root of 2. We have 3 raised to the power of 1 over 3. This is equal to the cube root of 3. So if you have 4 to the 4 to the raised to the power 1 over 2 is equal to square root of 4. So that's just it. It's used to show the indices of different roots. Indices of different roots. That's just it. Hence, we say that when we have a to the power of 1 over 2, it's equal to square root of a, and a to the power of 1 over 3 is equal to the cube root of a. Does that make sense to you? Now we go over to the last one. We have the fraction index. It says that at times a number might be raised to the power which is a fraction other than just 1 over 2, 1 over 3. It can include 3 over 5, 6 over 5. It has to do with proper and improper fractions. So how do you represent such a number? So if we have 4 raised to the power 3 over 2, this is equal to square root of 4 to the power of 3. So if we have 5 raised to the power let me say 2 over 4, this is equal to the fourth root of 5 to the power of 2. Does that make sense to you? Say if we have again 8, if we have 8 raised to the power 4 over 3, this is equal to the cube root of 8 to the power of 4. Generally now we can say that a the power of m over n is equal to nth root of a to the power of m. Thanks for watching.